This is a talk about, I call it reverse engineering the clean code. At some point, I called it design principles for developers. And to a certain extent, it's pretty much psychology one-on-one. This is a quickie. This talk evolved from an hour talk into a quickie, into a lightning talk, and then again to the quickie. Because if you think about anything related to cognition and how our brain operates, it's enough to write a PhD, not talking about putting it into a quickie talk. So what we'll be talking about is not only the clean code. I've given this talk a couple of times. You might have heard it on GeekCon, for example, 2 years ago. This is not the same talk. The content evaluates and changes, and you will see in a second. My name is Kuba Marchwicki, and you can catch me up here on the conference or on Twitter. So whenever we think about clean code, this is the picture. This is the guy we think of in the first place, the angry look of Uncle Bob. And usually when we come across clean code for the first time, this is on our first steps of the journey from very junior person to mastery. And when we look at clean code and when we use clean code, the first and foremost principle is that what we would like to avoid is a situation when we wrap and code some stuff, and then after 3 weeks when we try to look at it, we have no idea what we've written. And this is on a very basic level understanding the clean code. But as we get into either Uncle Bob's books, or we get into some other authors, we usually come across Kent Beck. And Kent Beck wrote a book about implementation patterns, and he pretty much took, from my perspective, clean code to the whole new level. That it is not just about writing clean code, it's about certain values and principles we have as a team, and that makes us go faster. And there are, principles about communication, about simplicity. And the next thing is that, you start to think that what is Solid really about? What is clean code really about? And there are yet another talks for guys like Kelvin Henney who try to distill clean code into very, who try to distill Solid into, every small bit. There is a very good talk from him about Solid deconstruction when he puts a thesis that from all the clean code, what matters is a single responsibility and list of substitution, and that brings us dependency injection, and that's all that matters. So if those great guys are talking about clean code and Solid, what's my role here? So I'm giving it a small twist because I'm trying to look at clean code from a perspective of psychology, of how our brain operates. And this will be a little bit of psychology one-on-one. Last year when I was giving this talk, I was talking about the affordance. Affordance is a quality of an object which allows an individual to perform an action. So if I see this microphone, I naturally know how to use it and how to operate it. And I use it like this, not like this. Because this as an object affords certain qualities that signifies me how I should be using it. What action should I perform? The knob affords pulling, while the doors, for example, affords pushing, and that's kind of natural for us. That's how our brains operate. But if we look at the same principles from the code perspective, and if we see a code like this, it naturally signifies how I should be extending it, what I should be adding to it, and how I'll be looking at it. And I'm not saying it's a good code, because if you do the same thing with multiple classes using some additional design patterns, then the same functionality signifies you how you should be working with it and what should be done with this code, how this should be extended, how we should be adding the update functions. And there are many other things in psychology, like the affordances, which I've shown. There is this whole aspect of accidental complexity, known also as confusion, how to not confuse people. There's lots of about attention span, how our memory works, about short-term memory, about the long-term memory, about, there are many frameworks in psychology. There is the concepts of flow. What I'll be talking about more today is the memory model. So how our memory works, and what it makes that, and how it impacts the way we are working, how it impacts the way we design code. So if we look at into some papers on the memory model, on how memory operates, the most famous one is the so-called multi-story memory model. So we have multiple stories in our memory, which we have multiple stories in our memory, and each one is responsible for a different part, for something different. The first and foremost, the most natural one, the most frequently used, is the sensory memory. This is something when an information is stored in the sensory memory, it is stored for a very short amount of time, less than a second, and we can store there lots of information. It's everything that is responsible to our, senses and how we touch things and how we look at things. Things get interested if we move a little bit further and we get into short-term memory. Short-term memory is something that, and you all probably had this feeling that you just read something, and you got distracted, and you totally forgot what you've been reading about. This is a memory that lasts for about 20 seconds. It lasts until the next distraction happens, and the information just goes away after the time. And the third one is a long-term memory. Long-term memory is like hard drive. We can write lots of things there. It's probably, that's the most recent papers, it's probably limitless. There is no limit how much we can remember. The problem is that if we are to remember something, we have to learn it, and learning takes time. It requires constant rehearse process, and that's when the information from the short-term memory goes into long-term memory. Okay, so if we treat a short-term memory as a kind of a RAM drive that's volatile, but is very quick, and the long-term memory as a hard drive, as an optical disk where the writing process needs time, how it impacts the way we look at code, and how it can impact the way we are writing code. So another code example. If we get a code like this, taking, putting aside it's very convoluted, it's just bad code, we hardly ever can remember, like from the glimpse of an eye, what is going on. We have to learn it. We have to learn it step by step. And this is actually coming from one of the production systems I've seen. So if it's not only about the very bad code, it's about how we approach certain things while writing, like how we approach naming. When we put short, self-explanatory names, we don't have a problem of remembering, or others who are using our code or our API do not have the problem of remembering what exactly was this function about, or what exactly was the name. It's just, they have a look, they just do control space and have the autocomplete, and they out of the box naturally know that this is exactly what they are looking after. The next thing is about consistency. When we put some consistency in our APIs, in our code design, then each and every name means the same in every place in our code, then we don't have to learn it, or we just learn it once, and then we can use it. We don't spend time on the constant learning process of the new code, and that's where we get effective. Or if we put a limited number of parameters into our functions, and each and every parameter is properly ordered throughout the code base, then again we just don't have this constant learning process of putting things to our long-term memory to sit there and remember. If we did this process once, it stays there forever. Probably if you've ever worked with some, old, not fancy anymore stuff like the SOAP web services or Corba, you still remember those APIs, you still remember those classes and methods because you just learned it, and it stays there. And you can make fun of them after a while, but it stays there. So what we are pretty much talking about is something that people refer to the principle of the least astonishment. So when we write our code, it should be least astonishing. It means it should put people into least possible troubles or astonishment, that they don't understand it and they don't know it. And to show you how exactly it looks in some code snippets and how this principle works in some code snippets, let's see of some API examples. If we get a Java SQL statement class, every method that is used to execute something is having an execute part in it. Whether it's a batch, whether it's a query, whether it's an update, it is always execute. And we don't have to constantly learn different methods to do different things. We just remember one thing, that it is something related to the execute, and that gives us all the information, that gives us all the clue, and takes us through whole API if we are using it. If we take another example, like Collections API, the Collections API is built in such a way that every method is using size, every class is using size, remove, and remove all. If we would like to have a size of a collection or size of anything that's related to collection in Java, then we use size, and that's obvious. However, if we look at the other API, which is Java Util Observable, they don't follow that principle. And we have a new API to learn. Because if I have an observable and I would like to count observables to get the size of the observables, no, there is no size method. You can have to count observers. And I would like to remove observers. No, I don't have a remove. I have delete observer. And delete all observers, not remove all. And then that way we have a new API to learn and a new process of learning, of putting things into long-term memory, and we have to work through that. So the less troubles we are the less trouble, this kind of trouble we are putting into our code, the faster people work with it. And we are more effective, and it's more pleasant, and so on and so forth. And this is not the only example. If we take a Java string class, it has a pattern matching method, which takes integer string into integers, and all of a sudden it has the same function, well, called it the same, but it takes Boolean in the first place. Like, what? It's about, ignoring cases. But now we have pretty much the same functionality, but the same parameters, but put in different order. And then again, we have to learn it. I had to learn it, that this means ignore cases. The funny thing is that I don't remember all the other parameters, but I remember that bloody Boolean, that's ignore cases. So there are many cognitive limitations, and there are many limitations in our brain that makes us work in one way or another. If we try to embrace it, if we try to understand it, what they are about, then I think we can work with the code easier, and it makes our life much more easier. So as a final slide, what I would like to propose you is the next time you will be looking after a book to read, don't rush for another framework, don't rush for another fancy stuff coming from IT. Just take a look into a totally different world, which is not explored in IT that much. For example, the design of everyday things. So a book about physical object design, written by Don Norman, which pretty much covers all those principles, and to give you an ability to look at things from a totally different perspective. So thank you.